Hello everyone, in this video we are going to explore a new feature of the LuBan cutting method. Let's open LuBan software and then we drag a cylinder model into LuBan window. This model is a cylinder with an angle. If you use mesh cut and the method set to modular cut, you will see a new option called axial cut. In the previous version, we have an option called natural cut. I have disabled that option in the latest release because the natural cut algorithm is not stable, and I think it is better not to release it. The axial cut is a new feature. By its name, you will see that if you set it to yes as the default value, the cuts will be only parallel to x, y, or z axis. If you set it to no, then you will allow non-parallel to x, y, and z axis cuts. So let's take a look at this cylinder example first. We set axial cut to yes, and maybe we set the z direction height to 300. If we just go ahead and cut it, I will disable the connector. The cylinder is cutting to 4 pieces, but the cuts are horizontal, so it's not very nice. If you set axial cut to no, you allow non-axial cut, then we cut again. It is still cutting to 4 pieces, but the cuts are parallel to the end surface of the cylinder, so it is a beautiful cut. In this particular example, both methods, both axial and non-axial cut, resulted in 4 parts. But sometimes axial cut may produce fewer parts than non-axial cut. The non-axial cut has the advantage of producing more pleasing cuts, obviously more pleasing cuts, but it does not necessarily reduce the number of cuts. Our traditional axial cut is purely based on the printer size. So if it's out of the printer in X, Y, or Z direction, then we will cut in X, Y, and Z direction. So it's a brute force cutting, brute force decision making. And very often, that type of decision making gives you fewer number of parts, but the cuts are ugly sometimes. This is an extreme example showing the advantage of axial cut. I will also show you another example in which you will find the situation is not suitable for non-axial cut. So let's close the current object, and I'm going to open sphere. A sphere model. A sphere model is not suitable for non-axial cut. Once we do an experiment, you will see why. Let's set it to 300 z direction height. And every time I enter a new value, I hit the enter key to update the display. Axial cut setting is set to yes. It will only produce x, y, z cuts parallel to the axis. This is what we would get in the existing version of LuBan, in the old version of LuBan. You get a blocky cuts. If you set the axial cut to no, then you allow for non-axial cut. You start to get some weird effects. Because it's non-axial, then the algorithm is trying to select cuts at certain angle. Sometimes it produces cuts parallel to axis, but other times, more often, it produces cuts not parallel. And in this case, we have 34 parts. And if we open the previous one, axial cut, we only have 23 parts. So in this case, when we load a sphere model, the axial cut is much better. The cuts are more natural, and you got fewer parts. How about, in our last example, I will load an organic model. Oh wait, wrong model loaded. And this is a human model performing martial arts. We go to mesh, cut. Okay, at the beginning, maybe we set it to 300 Z height. And then we will perform an axial cut. It takes a little while. We have 8 parts. And if we use the shortcut key explode E, we can see these cuts. The cuts are fairly good, except that the middle section, the torso, gives us 2 regions that are connected on a very thin area. This is a little bit difficult to deal with. How about we switch to non-axial cut? Set it to no. All settings are the same except the axial setting. It gives us one fewer part. It has 7 parts. The previous one has 8 parts, and the torso is cut in a much better way. Taking the non-axial cut, the torso is one whole piece without cutting in the middle. And the legs are cut in an angle determined by an algorithm. So what if we increase the height to 500? How about we increase the height and produce more parts? Producing more parts. For the first test, I will set it to axial cut. This is our traditional way of cutting. We get 19 parts, and these 19 parts are cut in this way. The middle torso is further cut into several pieces, but look at the pink one. The pink one is the one that we had a problem. It has a thin connection between 2 blocky regions, and this is part number 12. So number 12 has a middle region that's very thin, and when you actually 3D print it, this part may break. Okay, let's turn to non-axial cut. Give it a go. It produces 18 parts. The previous one is 19 parts. So in terms of the number of parts that the 2 algorithms produce, it's similar. And based on my test, sometimes the axial part will produce fewer parts. Non-axial part will produce more parts. And in this example, we're just lucky. These are the cuts made by the non-axial cutting algorithm. So it's different cuts. And in this example, I think each part produced by the non-axial cut is more robust. It's less likely to break into 2. That is all. I hope you like the option of axial cut. You can set it to yes and no. See you next time. Goodbye.